Hi guys, we're doing the same thing we did yesterday. I just thought I would do a few more examples for you just to refresh. When we finish with this, there is an assignment and it is in today's folder and it's called Solving Exponential Equations. I want to say there are 15 problems. Here's a strategy for us to use. We want to try to obtain like bases. When the bases are equal, the exponents are equal. This is referred to as the one-to-one property. So for instance, if you had 5 to the x power is equal to 5 to the second power, we know that x would have to equal a 2 because, of course, 5 squared is going to equal 5 squared. So that's our goal. We want to get our bases to be equal to each other. So here's one. Let's try a couple little problems and make sure we got this down. I'm going to rewrite 36. I know 36 is the same as 6 squared to the x plus 1 power equals 6 to the x plus 6 power. I know from yesterday I learned that when I have a power to a power, a power to a power, I multiply my powers. That's the only time you multiply powers. So I'm going to have 6 to the, make sure you distribute. That will be 2x plus 2. That's a place where we can make a mistake if you forget to distribute. So be careful. Now that my bases are equal, then my powers have to be equal. So I'm going to drop my bases and I'm going to set my exponents equal to each other. So 2x plus 2 would have to equal x plus 6. And now we solve for x. So I'll subtract x from both sides. So I have x plus 2 equals 6. I'll subtract 2 from both sides, and x will equal 4. Now I could, and I should, plug 4 in and check it into the original problem, and the left side should equal the right side. When that happens, I know that 4 is the correct answer. It is correct, though. I've already checked. In this problem, in this next problem, I'm going to have to rewrite 1/2. I'm going to have to use a negative power. That is 2 to the 1 over 2 to the first power, which would be 2 to the negative 1 power. So I took it from being happy, 2 to the first, being happy in the bottom of the fraction, and I brought it up, and now I made it sad. I made it negative. I gave it a negative power instead of having a positive power. And we learned that yesterday as well. And 64 can be broken down to a base of 2. It is actually 2 to the 6th power and then to the 1/2. I know from yesterday I learned when I have a power to a power, I multiply my powers. And same thing, when I have a power to a power, when I multiply 6 over 1 times 1 over 2, I get 6 over 2, which is 3. So that comes out to be 2 to the 3rd. If my bases are equal, then my powers are equal. I literally can just drop the base out of the problem and set negative c equal to 3, divide by negative 1, c equals negative 3. If I plug negative 3 back into the original problem, it will work. In other words, the left side will equal the right side, and we should be doing that, but I'm saving us a little bit of time. The next problem, I'm going to look at my two bases, 16 and 4, and I want them to have the same base so that I could use the one-to-one property. So I'm going to change 16 into 4 squared. And then it's got the same base as the right-hand side. 4 to the 4x plus 7 power. When I have a power to a power, I multiply my powers. That is the only time you multiply powers together. And don't forget to distribute the 2. So we have 4 to the 2x plus 6 power equals 4 to the 4x plus 7 power. When the bases are equal, the exponents are equal. This is called the one-to-one property. One-to-one because they're in the same position. So I would know that 2x plus 6 is equal to 4x plus 7. I would subtract 2x from both sides first. That would give me 6 equals 2x plus 7. Subtract 7. That would give me negative 1 is equal to 2x. And divide by 2, and I get negative 1/2 is equal to x. You should plug that back into the original problem, and the left side should equal the right side, and it does. Although this is an exponential equation, we'll need logarithms to solve. Don't worry, it'll be fine. I don't think there are any of these problems on your homework, but I just want to show you this one because it's super easy anyway. Remember that when we had 4 squared equals 16, that's an exponential equation. I can change that into the log form. Log form. It's log. The base goes down here. The answer goes here. And the exponent, logarithms equal exponents. So the exponent goes on the right side. So I'd have log, my base 4. It goes in the basement, down low. The answer is the 16. That's what it equaled. And the exponent is the 2. So if I were to apply that same pattern to this, it would say log, my base is the 4, the answer is the 13, and the exponent is the x. This is the exact value. Log base 4 of 13 is what x equals. And if I were to get out a calculator, the decimal value is 1.85. And of course, this is a rounded off version. This is the exact value, and this is a rounded off value. Remember, we took out our Desmos calculators and we went to functions, and then under function, we went to miscellaneous. And then you'll see the log base key, and you'll see just a regular log key, and you'll see a natural log key. But anyway, that's how you do that. All right, guys, have a great day. And your worksheet is also in our folder.